Welcome to the viewers. Now we discuss the linear dependent and independent vectors, and which is very much useful in many cases, and it is an important branch in linear algebra. At first, let us take a look the criteria of linearly independent and dependent vector. If suppose the vectors given by x1, x2, x3 at the basis of the vector are called linearly independent if there exist scalars c1, c2, c3 such that c1x1 plus c2x2 plus c3x3 is equal to theta, where this theta is the null vector 0, 0, 0. And at first we consider an example, and it should be clear with the help of an example. If we consider the basis of the vector, suppose in the earlier video I already discussed the vector like this 1 0 0 0 1 0 and 0 0 1. Then if we test it, is either it is linearly dependent or linearly independent, and here is the criteria where theta is this, then when c1 is equal to c2 is equal to c3 equals to 0. That means if all scalars are 0, then we call linearly independent. It is our criteria. Therefore, we test it. If these three scalars c1, c2, c3 are 0, all are 0, none of them are non-zero, then we declare it as linearly independent vector. Then c1 into 1 0 0 plus c2 into 0 1 0 plus c3 into 0 0 1, if we compare with theta, that is c1 into 1 0 0 plus c2 into 0 1 0 and c3 into 0 0 1 is equal to 0 0 0. If we compare it, c1 plus 0 c2 plus 0 c3, that will be 0, that is c1 is equal to 0. Similarly 0 c1 plus c2 plus 0 c3 equals to 0, that is c2 equals to 0, and 0 c1 plus 0 c2 plus c3 equals to 0, that is c3 equals to 0. So we find the scalar c1 is equal to c2 equals to c3 equals to 0. Since all of the scalars are 0, therefore these vectors like this 1 0 0 0 1 0 and 0 0 1 are linearly independent. We declare it, and that's why, since they are linearly independent, so they make in the three-dimensional axis system with the help of the coordinations, and with the help of this we draw axis system here. Now next we discuss the linearly dependent vector. If C1 x1 we use as assumption of precondition C2 x2 and C3 x3 is equal to theta, where C1, C2, C3 are scalars. If at least one of C1, C2, C3 is non-zero, then vectors, like if we consider here x1, x2, x3 are linearly dependent. Like this, if we consider like these vectors 2, 3, 1, if we consider a basis 2, 3, 1 standard basis, 1, 0, 1, 0, 0, 0, 1, 0 and 0, 0, 1, then we can represent it, we find easily. Now here we will change these terms, because we find easily 2, 3, 1 can be written as 2 into 1, 0, 0 plus 3 into 0, 1, 0 plus 1 into 0, 0, 1. So it can be written as this way. So this vector depends on the three vectors. So this is linearly dependent vectors, and we find here the scalars, these terms we used. Though this is not come from our definition criteria, we just give here simple concept and simple idea to clear this, how linearly dependent vectors occurs. And my video is too much longer, that's why in the next video I will discuss from the definitions of linearly dependent vectors, like the linearly independent vectors. So I give some ideas. We end our discussions. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.